Welcome back to Tools and Track. It's blowy, it's spring. We're getting close to something being ready for summer. Today it's time we do this. I was kind of hoping you'd be working on it, but we're going to do this engine. Whereas I would probably just trust the manufacturer and chuck the pistons in.
No.
This is not the Daniel way of doing things.
It is not.
So this is how you will properly build an engine. Today we are measuring things.
We're going to check the size of these bores and then check the size of the pistons and put the caps on and check the size of the bearing tunnels.
So realistically, I have taken liberties with in the past because I've had it machined out by a known engine shop. This guy has allegedly been taken out to 87mm.
Yeah.
87. But we want to verify that.
The problem with that though, right, is you get a machine shop to do it. Yeah. You're still relying on them doing it right. Which is, you know, yes, you might find a good machine shop that'll do it right, but you see quite a lot of times places stuff, the machine stuff and the clearances are all wrong.
Plus, we are also putting in pistons of an unknown quantity as well. Now, they are marked as an 87, but 87 point what. So that is why the accuracy here is required. So
Plus, you should always do this. See, if you're building any engine, it doesn't matter if someone else has machined it and you trust that you should still do it. Because if it goes wrong, it's at the end of the day, it stops with you. Yeah. You should have measured it first and checked it was right.
So that thing, that stops with me. All right, smart arse.
If anything's too tight,
you're going to
people will know quickly, because if your bearings are too tight, you'll spin a bearing. If the bores are too tight, you'll scuff the pistons. All sorts of bad stuff will happen. So a wee bit on the loose side is fine. Too tight is not.
So this is phase one of the measurements. Now don't worry, we will explain this. What we have done, first of all, was measure the bores.
Yes, so dial bore gauge, down the bore, measure the size of the bore. I've done a quick kind of checked at 90 degrees and it's pretty round, which you would expect because it's been honed. You would hope it's round, but it is round. So we've measured all 4 cylinders, got the sizes.
That gives us along and across, so we've done the math, and the bore tops are as those.
Yeah. We'll do the middle and the bottom, but I just want to do the top just for a quick
we're matching check. Pistons to bores here, so this is phase one. The next thing we did was measure the piston across various intervals and took an average, so they turned out to be quite accurate. So
yeah, they're fine. They're what you would expect them to be. Yeah. They're as close to 87. I mean, that's the thing, like a lot of pistons say they're 87mm, but they're not
actually
exactly 87mm, because you find, especially with forged ones, right, they expand a lot. They tell you to use a wide clearance on them, right, but a lot of time they still undersize them slightly because of that.
And that's a point to note. We're not doing the VG, the VQ, the very 300ZX ones. We're going with the Gs.
The reason that we're going with these, right, is because we actually kind of have to, because the measurements from this block are a wee bit too big for the gas pistons, standard for gas pistons.
So as a result, the measurements of that and that, we've took the delta across, which is basically the gap, and we found that we get 0.13, 0.16 and 0.14 for the last two. Now, this is why you measure an engine, because what that allows us to see is, if we were to swap piston 1, which is big and piston tight, which is slack, with the bores, which is big and tight, basically change 1 and 2 around.
You can kind of balance it.
That gives us a balance, a good equal spread.
Yeah, if it was me, I would go a wee bit tighter than that, but the thing is
they'll match now.
On a set of forged pistons, that will be fine. The alloy these are made from, I can't remember the actual exact alloy, but the alloy these are made from, right, these expand even more than some of your newer ones. A lot of your really, really modern forged pistons, they don't actually expand as much as these.
Size quite well.
So we will need to have a wee bit extra. So being at 6 thou is absolutely fine. This block has had quite a bit of machining done on the deck. So if you go and machine the deck, the oil pumps on these basically have got dowel pins that locate. So that it ends up in the centre line of the crank when you obviously fit it, so you don't obviously damage the pump. But the issue with that is if you then go and deck the block,
standard height
the pump can actually end up too high. And I've seen this before. What happens is you put them on, you go to put the head down, you go to turn up, you hear a crack, and you've just cracked the whole top of the oil pump assembly because it's sitting proud. So we'll need to quickly check that. If it is high, then we'll need to get it machined down.
So we've put the casing on, and understandably it is too tall.
Yeah.
Do the focus. What we do is we get feeler gauges and run the finger over until
I think 0.2 is maybe a wee bit too old. That's
0.25. So we need to take that. That probably makes sense because you've decked the head to
we've decked this block.
round number.
From the factory, these obviously, you need to remember, these will sit a wee bit lower by design, but we've obviously
taken all
in
of
hindsight, what we should have done was we should have gave this, but at the time we didn't actually have this yet because it had to get special ordered, so
that will need machined.
It will need machined.
So we're not going to do this yet, but at least we've done this in advance so we can get that dealt with. Then there was a girdle.
Yes. So next step, we'll put the ARP studs in and torque them to the ARP spec with the shells in, and we'll then measure the size again so that we know if the ARP studs and the extra torque has deformed this in any way. So what we're doing just now is we've done this. This is standard pulsar bolts torqued to the standard pulsar spec. So we're going to do this. They're all done. They're already torqued spec. So we'll measure the bore of this tunnel. Measuring the crank's bore just for later. All we're going to do at the moment is this just going to tell us what this has been machined to. The ARP bolts shouldn't deform it too much, but it will. It's impossible to avoid. These are torqued a lot lower than what the ARP ones are. So no matter what people say about, you could just put studs in and just torque them up to the ARP spec and they'll be fine. That's not always the case. Sometimes with some engines you find you torque them up to the ARP spec and you will really badly deform this bore, which will most likely end up in you pinching a bearing. The last check we'll do is we'll actually put the bearings in, torque it up to spec with the bearings in, and actually measure the diameter of it with the bearing fitted, and then because we'll have the crank measurements, we'll then be able to see what the exact clearance is.
Now that might seem all nice and happy and great technical measurements. The problem I've got with this is I've done this sheet to measure pistons 1 to 4, and this f***ing thing has 5 main bearing caps. New sheet. That was going really well until we worked out that this completely obliterates that access, and so it's off. Anyway, number 4 please. So we're back on the stand, which is good. We've got our measurements. So I'll do the measurements. You can tell me if it's in spec. We have from cylinder 1, 58.96 down to here. And then we're looking 58.955 to 58.95 towards the back. So getting slightly tight to the back, but was it in spec?
That's fine. So 58.944 up to 968 is the min and max on that tunnel size.
So we're a bit in the slack side, but fundamentally within manufacturer's specs.
Yeah.
So the good thing about being slack, as you've mentioned, when we put ARPs in, there's a fairly high chance that they're going to provide more torque and force, and therefore pull that slack into a tighter bit.
They're going to distort the main caps very slightly, but how much we don't know. But we'll find out.
I don't think it's going to be wide, because if ARP are manufacturing it to be used on a OEM block, then you've got to think it's within the tolerance.
They do recommend a line bore on all of them.
Well, we ain't doing that. Let's get the girdle back off and get the king bearings in.
We also need to do, the last thing we need to do before this can get built,
for fuck's sake,
is piston ring gaps. So these are not sized in any way. If you buy like a set of standard rings for a standard engine, most of the time they're already sized within specs, so you just chuck them on, put them in, away you go. These are not. So they deliberately leave these tight because they're for race use. So depending on what application you've got these in, you can run them tighter or looser. Like if you've got a non-turbo engine, you probably want to keep them tighter so that you can get better ring seal. But turbo stuff, you get loads of heat, loads of cylinder pressure, you want to run them a wee bit looser. Unpackaging.
I heard something hit the ground.
Nothing hit the ground.
Really? I heard a tink, tink, tink.
Nothing hit the ground.
Right, so it is time to actually build now that it's been freshly machined. So what are we doing here?
Fixing a common SR20 problem.
Not just a common one, but you suspect might be the reason this engine grenaded.
Yeah, remember we had loads of bits that
Yeah, we couldn't work out what it
we
was.
couldn't figure out where the metal came from.
Yeah.
Yeah, well, when we took this apart,
It's,
there's see that?
yeah.
Yeah, there might be one of these in here.
Yeah. So the timing chain basically runs up through here, and
Yes.
that is like a garden sprinkler. Has two wee. It comes out as a plug, and has two wee holes in it, and it sprays oil.
It
left and
sprays the
right.
chain of the guides to stop the chain and guides dying.
Yeah.
So
But that was missing.
yeah, but this is actually quite a common thing. So if you've got an SR with a really good oil, but a brand new oil pump, and you've got slightly thicker oil and stuff, these are just pressed in from the factory.
Okay.
So what happens is if you get more than like 90 psi, you will just eject that.
It'll just pop out.
And then it'll go down the sump. So we think what's happened is it has ejected it.
Yeah.
And then at one point I've drained the oil and it's came out. It's came out the sump.
It will not just drop all oil pressure, just enough for that to just go and spray oil out.
Yeah, so the problem is this, we don't know how long this ran with lower than what it should have oil pressure.
Yeah.
So, because there's oil pressure gauge of the car, and the oil pressure, it was lower than what you would probably really ideally want.
Right.
So, but I don't know when it happened. So it could have ran for,
Days, weeks, minutes, who knows?
year. But the key thing with this is, right, you got to thread one, it could unscrew. But what they've done is they've made it long enough that when this is fully threaded in, it just misses the oil pump cover.
So even if it screws out, it's still going to butt against the
So it's only going to unscrew, like literally let it turn and then hit the
Now,
cover.
I am not the best engineer in the world. I mean, I'm trying to be. I would have thought Nissan would have missed a trick with just not making that the same. Why wouldn't you just make that long enough so it wouldn't pop out?
Small box Chevrolets have got that press-in rocker studs. So
Ridiculous.
you put a set of valve springs in and then you just immediately just ping the rocker studs out. So
Anyway, so here's the fix.
team in.
Here's an audience.
Aye. Crankshafts, bearing clearances,
Right.
measuring them.
Measurements.
So there is multiple ways of doing this.
Can we just do the quick way?
The most common, plastic gauge.
Yes.
Which is fine. There's nothing wrong with plastic gauge. It does its job. It does the thing. It's quick. It's easy. But if you want to measure things accurately, the best way to do it is outside mic, measure all the journals, get your sizes for them, and then what we'll do after that, once we've got these sizes, we'll write these down, and then the block, we'll put the bearings in with the studs, torque the studs to spec, and then we'll use the dial bore gauge and measure all of the tunnel sizes on that with the bearings that are going in it, and those bearings will need to stay with those caps.
Yes.
And we'll do the same with the rods.
So we are joined by a lovely assistant who's going to write things down.
Is your handwriting good, Brian?
Lovely.
There you go, perfect.
It's probably better than mine. Right. Step 1. Measure.
Yours is really bad.
What's wrong with my
It is
handwriting?
quite bad. It is
What
bad.
is wrong with my...
It's bad. It's bad.
Disgusting.
We've measured.
There we go. One
There's a
freshly... Now, look at all the measurement that's happened. Measured.
Well,
Quite hard to
tell you
make
what,
that interesting
it's
content,
not.
but, you know.
It's really not that exciting. So we've measured them, and we've got a wee table.
Yes, so the table shows us the mains and the big ends.
Yeah.
So they're all within literally... They're exactly the same, frankly.
Which they should be. They
Yeah.
should be exactly the same. So you need to make sure that you've not got any error in your mics.
And you're in a temperature controlled environment, and you're not holding the mics too long, and
You
that
can
the
only,
crank's at
yeah,
stable
you
temperature.
can get to, it gets to the point it's ridiculous. But so what we've done is basically we've checked, there's, in those boxes, there's little calibrated,
Measurement.
they're basically a calibrated size, and you measure it with the mic, and you can see there, look, we've noted down, both mics read 0.01 of a millimetre high.
Yeah.
You know, so 0 is actually 0.01. So we've then corrected that at the right there, and then that's the actual sizes.
Cool.
So
Block
that's
next?
Yes.
Block.
Right, problem number 1.
Yeah, right. This has went well. So we've assembled these up so we can measure the bores to compare it to the crank and make sure the clearances are correct. And we're already humped because...
Yes. I phoned first to make sure, are these pulsar rods? Yes, they
Yes,
are.
yes, they are.
They definitely are. I says, are you sure? I says, because just remember that the bearings are different from a normal rod, like S13 DE rod to a pulsar rod, and they went, yes, the pulsar rods.
Pulsar. Notice nowhere does it say
Yeah.
pulsar.
So the problem that you have is this 17, 19 mil bearings. If we look in here, if you see the tangs, so on a pulsar rod they're evenly spaced, and on a non-pulsar, like a DE rod or a Sylvia rod, they're actually not equally spaced. So the problem is, if you put 19 mil bearings in, they don't align, basically. You won't actually get any movement in this, so what you do is you just run these with the 17 mil bearings.
Slightly thinner, which means slightly less strength, but fundamentally slightly more working because the current
We can't
solution
run,
is
yeah,
not
we can't run the 19 mil bearings because you've got like 2 hard edges, basically, where
So,
the misalignment is.
for any of you lunatics out there who are building one of these with a pulsar bottom end or whatever, you cannot run these Eagle rods
Yes.
as 19 mil
It
bearings.
turns out the only ones that actually take the 19 mil bearings are the Brian Crower ones.
Yeah. What will now literally be a scene change for you will be several f***ing weeks for us waiting for.
Well, we're hoping
correct
that
bearings.
it says 3-day postage, so that'll be about 3 weeks.
Tick follows talk, follows tick. We've been at this for too long, so that's going to be a total cliffhanger.
Okay, that's next.
That's going to be next time. So, next time, like, bell, subscribe, patreon.com/toolsandtrack. Catch you in a week. Drive safe. Block,
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 New kids.
block,
block,
New kids.
block,
block.
block.
Measure the block.
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 Let's measure the block.
Block.
Okay. Let's measure the block.
Measurement
Block.
of the block.
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 Measuring.
Block.
Okay, I'm done.
Okay.